In this question or in this video, we'll be solving question number 25 from GATE 2019 chemistry paper. Now the question says the gas phase bond length and the dipole moment of a compound Mx is 3 angstrom and 10.8 dBi respectively, and we have to find out the ionic character of this compound in the gas phase, or the percentage of ionic character we have to find out. Now the 1 dBi equal to 3.336 times 10 to the power minus 13 coulomb meter. So so in this question, the bond length of Mx, compound Mx, and the dipole moment of the compound is given, and we have to find out the percentage of ionic character in the gas phase Mx compound. So to compute the percentage of ionic character, that means how this bond is polarized. That means it is M. Let's say this atom is M and this atom is X, and this is Mx compound. Now we have to find out the ionic character of this bond. Ionic character means how this bond is polarized. That means so first we have to compute the dipole moment of this bond. First we have to compute the dipole moment. So dipole moment is computed like with the expression charge times displacement. Here charge is the charge of an electron, and here displacement R means the bond length of Mx compound. That means this distance. So R is the bond length. By this formula we can compute the dipole moment of this compound, which will be just theoretical or calculated value of the dipole moment. So the theoretical or calculated dipole moment will be just charge times displacement. So charge of an electron is 1.6 times 10 to the power minus 19 coulomb, and displacement is the 3 angstrom. It is given bond length equal to 3 angstrom. Now if you just convert this unit in meter, angstrom to meter, that means 3 times 10 to the power minus 10 meter. So if you put this value 3 times 10 to the power minus 10, so the dipole moment, calculated dipole moment, will be just 4.8 times 10 to the power minus 29 coulomb meter. Now if you convert this dipole moment value from coulomb meter to dBi unit, so you have to just divide this value with the transformation factor. That means 3.336 times 10 to the power minus 30. So the calculated dipole moment is 14.3 dBi. Now the ionic character is basically just experimental value divided by the calculated value. So this is the experiment. The ionic character is the ratio of experimental dipole moment. That means the true dipole moment. Experimental dipole moment. That means the true value divided by the theoretical or calculated dipole moment. Calculated value. It is the ratio of these two quantity. So the experimental value is given in the question, which is 10.8 dBi, and the calculated value is 14.3 dBi. So the ionic character will be the 75.5%. So the percentage of ionic character in gas phase Mx compound is 75.5%. So the trick to solve this kind of question is, first you have to compute the dipole moment of the given compound. Let's say it is Mx here. How do you compute the dipole moment? Just by multiplying charge of an electron times the bond length of the compound or of the particular bond. Now this will be just calculated dipole moment or theoretical value of the dipole moment. Now the experimental or the true value of the dipole moment will be given in the question. So you have to just divide this experimental value with the calculated value and take the ratio, and then that quantity will be the percentage of nitric character in the gas phase compound or in a particular bond. Okay. Thanks.